Okay, welcome back to your laboratory number 3 or activity number 3. This is for sieve analysis of coarse aggregate, or we are trying to get the grading, or we are going to grade the coarse aggregate. Okay, so the objective is to determine the particle size distribution and to classify the type of gradation of the coarse aggregate used. So reference is TM C136-76 and then ASH2T27-74. So these are the essential equipment that we need. Set of sieves, the 1/2 inch opening, 3/4, 1/2 to 3/8 inch opening, together with the number 4 and number 8 and the pan, and of course the cover, sieve cover. Containers, balance, trowels, sieve shaker or the mechanical shaker, and then oven. However, we do not need here the oven since we have a sample that is already dry. So these are the procedure. Obtain at least 500 grams, but as I've said on the previous that our balance can only take up to 4,000. So we will consider less than that, less than what is required. But supposedly if you're going to do this one, exactly you need the 500 grams and above, or 5 kilograms. Okay, so this is only to illustrate how you will do this grading of coarse aggregate. So that's it. But you need to bear in mind that the sample should be subjected to methods of quartering or use of sample divider. Again, that is explained. Why do we need to apply this one in gathering or in getting a sample size? We will not just get in any part of the stockpile. We need to apply quartering or use sample divider. Assemble the sieves, okay, from the biggest opening to the pan, of course, and then place the weighed aggregates on top of the stack of sieves, and then properly secure the sieves in the mechanical shaker, and then turn on the shaker for 5 minutes. So again, if you're using a shaker, you need to do it within 5 minutes, at least 5 minutes. And in case you do not have this sieve shaker or mechanical shaker, you will do it manually. You need to do it within at least 10 minutes. So weigh the aggregate retained in each sieve and then record it in the data sheet. If the sum of these weights is not within 1% of the original sample weight, the procedure should be repeated. Otherwise, use the sum of the weight retained to calculate the percentage retained in each sieve. Okay. What I did here is that we did not satisfy these 5 kilograms or 5,000 grams, or we did not weigh. I did not weigh this one initially. So I just approximated. As long as that is enough to represent the sample, then that's it. So the total that you will be writing here will be the total weight of all the retained on each sieve. So again, I did not weigh this one initially. So the total weight, you will get that one by summating the initial weight of each retained. Okay. So compute the following: cumulative weight retained, percentage weight retained on each sieve, cumulative percentage retained, and then the percent passing. Actually, that is just to accomplish this one. This is what you can gather from the video or from the activity that I did. And then it's up to you. Cumulative is just, let's say, you want to get the cumulative at 1/2 inch. All you need to do is add from the previous sieve on top to the 1/2 inch. If you want to get the cumulative retained, that will be added all throughout up to the pan, or actually that will be the total because nothing passes the pan. So everything is retained from the pan going up. So the cumulative retained here on the pan is actually the total, okay, weights of the sample. So percentage weight retained, again, this is discussed. By the way, this is discussed in your lecture. Percentage weight retained, that is just the percentage of what is remaining on this individual sieve in ratio to the total. Okay, so that is percentage. And then cumulative, the same, just like how you get your cumulative weight, but however, we are just putting it on percentage. And then the percent passing. Percent passing, how to get that one is, okay, 100 minus cumulative retained. Okay, that is the percent passing. Again, the cumulative retained means that is to be retained, from this level on top. So what will retain on that size is, of course, the bigger the size of that opening up to the biggest size, isn't it? So that is what is found here, cumulative weight retained. So whatever passes that one going down, that is the percent passing in each of these. And then making use of this, you're going to plot the gradation curve. Okay, all you need to do is plot this one. What is the percent passing versus the opening. Okay, you're going to plot that one, trace that one with a curve. And then, by the way, this one is to be used to compare if that is well graded or not. Okay, there's a standard graph to compare this graph that you're going to make. So now, why is the gradation important in the Portland cement concrete? Okay, you are going to accomplish this report, answer these three. Okay, so by the way, this form here, this given form to you is for you to complete that one, that will be your front page, and then the succeeding will be your reports. Answer all this one. Okay, if we did not discuss all of this, then you will do research. That is the purpose of experiment or laboratory. So here is the recorded video for the activity. Okay, so this is the set of sieves, okay, that is arranged from 1 inch to the pan. Okay, so we have here your 1 inch. Okay, that is 1 inch. You can read there your size. Okay, so that is in 1 inch. And then you have here your next, that is your 3/4, or that is your 0.75 inch, and then that is your 1/2 inch, and then here is your, what is this? This is your okay, that is 1/2 inch. This is your 3/8. Okay, this is your 3/8 inch. Okay, that is your 3/8 inch, and then here is your number 4. Okay, and then this is your number 8, and then we have here your pan, and of course the cover of the sieves. Okay, this will be the cover on top, so that we are going to put the set of the sieves together with the sample on the shaker, it will not drop, okay, or it will not expel. And we have here your trowel. This is your trowel, okay, and then this is a pan. This is the pan where we will be putting the samples. And then this is the important part here, your shaker. Okay, that is your shaker. We are going to put here inside there the set of the sieves with the sample on top, and then we are going to on that one, so that that will shake. Okay, so that the smaller aggregate will pass going down, and then that will be happening within almost 5 minutes. So that, and then we will stop that one, and that's the time we are going to get the percentage retained, or the weight retained in each of the sieves. Okay, so for you to accomplish the needed data. And we have here your balance. Okay, this is a sensitive balance, that is electronic, so it will measure up to 0.001 gram or 0.01 gram. And this is our sample. Okay, this is our sample. If you are going to recall the condition of our sample, that should be clean of dust, so that should be washed. Okay, clean of dust. And then of course it depends on the type of the aggregate that you are going to use, if that is rounded and so on and so forth. That is discussed in your lecture. Okay, so we are now in complete set, so we are going to start our experiment in grading our coarse aggregate. Okay, so procedure number 1 is for us to prepare at least, okay, 5,000 grams, or that is 5 kilograms of sample. But in our case, the balance can only carry up to 4,000 grams. So this is just to give you an idea. Okay, so this is almost 4,000 grams together with the pan. Okay, together with the pan. Okay, so next is we are going to assemble the sieve. Okay, from the biggest opening, of course, to the smallest, and of course to the pan. So that is arranged decreasing size of the opening. So we already set that one on the shaker. Okay, the shaker will be the one to shake this sieve for the smaller size to go down. Okay, so now we already we already put the sample on the sieve. Okay, so on top, and now we need to cover this one using the sieve cover, of course, so that that will not, okay, will not be thrown away. And then now all you need to do is on the shaker for at least 5 minutes. Okay. Okay, so that is almost 5 minutes. Okay, the video is just cut, but of course the shaking of that shaker is almost 5 minutes. So now our next step is to get how much weight of that aggregate is retained in each of the sieve, and that is what you're going to record on the table. Okay, that is what you're going to record on the table. Okay, so after 5 minutes of the sieve set on the shaker together with the samples, this is now the result of that. Okay, this is the amount of coarse aggregate retained on the 1 inch. This is for 3/4, this is for 1/2 inch, and that is for 3/8 inch, and we have nothing. Okay, who passed this 3/8 inch going to your number 4 and then number 8, and of course what we have here is just a small dust. Okay, but if again your aggregate is totally clean, then there will be no dust. Okay, so we are going to weight this one. Okay, we are going to weigh this one and then get the weight in each of the sieve. So again, this is for our sample, but for other sample there will be a percentage of that on this small opening of sieves, but this is for our sample. This is already a sample that is being used here in our laboratory. Okay, so that is now the weight retained in your first opening, which is 1 inch. Okay, by the way, you have here your 417.7 something or 6 something there. You can actually neglect about that point gram. Okay, the decimal of the gram, we can say that is 41. You can say that is bigger than half, so 418 grams. Okay, so that we will not be getting the up to a second decimal, since of course that will not equal exactly to the total weight that we used a while ago because of other factors. Okay, so we will try to round it up. So 418, you can say this is 418 or 417.5, you can say that. So this is your 1 inch. That is the weight retained in your 1 inch. And that is the weight retained in our sieve with opening for 3/4 inch. Okay, 3/4 inch. You can say that is 1,840. Okay, 1,840 grams. Okay, and that is the weight retained in our half inch. Okay, weight retained in our half inch. You can say that is 934.5, or you can say that is 934. And that is for the weight retained in our 3/8 inch. Okay, that is actually the last of the total aggregate, because as we've observed a while ago, there is no aggregate passing that sieve 3/8. Okay, so there is 0 retained on your number 4 and then number 8. Okay, so that is the last part of our total aggregates. So you can say that is 35 grams. Okay, that is retained in your sieve number, or sieve with opening 3/8 inch.